Good, good. So just to help understand where blockchain applies, I'm going to talk just a little bit about the functions of blockchain. Not the details of how it works, but what do people use within blockchain. Then we've analyzed 36 applications of blockchain in the industrial space, and I'll give a kind of a summary of what we learned from that. I won't go through all 36. And then I have a slide on a couple of the major types of applications. And after that, I'll introduce our speakers. So, in a nutshell, blockchain is used for business process automation among independent entities that may actually be somewhat competitors, all right? So one of my peers likes to call this frenemies, but for the most part, it's business process automation among frenemies. And there's two cases that I'll talk about. One is where you'll have a central authority, and the nodes there may be nodes on a supply chain, for example. The nodes send information up to the central authority. The central authority knows what's going on, but quite frankly, each one of the nodes are blind. They don't know what's going on. The left hand does not know what the right hand is doing. All right? And then there's another area that's a common application, which is replacing manual methods. So particularly in global trade, there's a lot of email, fax, surface mail, a lot of documents that get passed back and forth and get approved by both the traders and government authorities. So that is error-prone, labor-intensive, not very agile, takes time. So by using blockchain, we're able to automate that and make global trade a lot faster, less expensive, less error-prone, and more agile. All right? So on the right-hand side, what we see is on the bottom between the nodes, the supply chain, and there is a distributed database, meaning that the entire database is on multiple nodes. And everybody can read that data and write to it so that the left hand knows what the right hand is doing. Documents are shared more automatically, trading information, et cetera. And it enables business process automation, again, among people who sometimes may be competitors, but it's to the benefit of everybody if they share information. All right. Now, what are the major functions? Well, number one, it identifies what an asset is. So we could take a case of mangoes, for example. It identifies a case of mangoes. It knows who owns that case of mangoes. And if that person decides to sell it, it allows for a secure transfer to a new party and a record of that that everybody knows about. All right? So there's visibility to all the participants. Now, what this also means is that when everybody can see it, everybody, in essence, there's a single version of the truth. And also, the data in that blockchain is itself immutable. But also, if someone decides to put in data that's not true, that's part of the permanent record, can't be changed. Eventually, it will be discovered, and that person or entity will be identified. So there's kind of a natural reinforced inclination to be honest about the data that you put into the blockchain. Right? And it enables coopetition among a consortium of shared members, shared interests. And I'll emphasize here, this is not a case where the central authority imposes something on the members of the supply chain, and the members of the supply chain do all the investment, and the central authority gets all the benefit. Like a particular large supplier tried to do with RFID about 10 years ago, 5 years ago. In this case, everybody invests, and everybody gets a benefit. Okay. So this is about as technical as I'm going to get, because people ask, what's a block and what's a chain, so I feel this need to just kind of cover that a little bit. It is a distributed ledger, meaning that you have a bunch of nodes, people participating in the blockchain, and each node has a copy. And as a result of everybody having a copy, if somebody tries to edit one version, there's governance to identify that and purge it. So it is immutable in the sense that once the data is in the blockchain, it cannot be modified. And there are multiple layers of encryption. There's multiple sets of business rules to do the governance. And I want to caution you, when you read about blockchain, usually the author tries to do a one-paragraph summary of how blockchain works and the technology works. And you just can't do justice in a paragraph or two. And almost always, people come away from that and say, well, geez, with a database and a little cryptology, I could do that myself. You can't. Blockchain is very robust and complex in ensuring data integrity, immutability, and purging bad stuff. All right. Now I'm going to talk about that graphic just a little bit. In the case of Bitcoin, because Bitcoin is a cryptocurrency built on top of blockchain, so what enables Bitcoin to exist is the blockchain infrastructure. Bitcoin's been around for 10 years, and Bitcoin has been proven to be viable over a 10-year period, so that has allowed people to have confidence in the blockchain technology and now use it in industrial applications. So in the case of Bitcoin, the clock starts, and for 10 minutes, every transaction in Bitcoin on the face of the earth goes into that block for a 10-minute period. Then at the end of the 10-minute, the timer closes, and the next block starts. For 10 minutes, every transaction on the face of the earth goes into that block. And then the second block gets attached to the first block, and you wind up with a blockchain. Now, and you may say, well, Ralph, what happens is at the end of the 10 minutes, one node that's accumulating the block, it's not quite in sync with another node, and a few transactions are in one block, and in the other one, a few transactions is in the other block. Well, there is governance among the different nodes to decide which one is the valid block, and then everybody runs with that block in that chain. After 10 years, just to put some numbers behind this, the blockchain underneath Bitcoin is now up to about 150 gigabytes with a G. That's a big file. If anybody opens up their PC and does a right mouse click on their hard drive and looks at the properties and see how many gigabytes are in it, it's highly unlikely you're anywhere near 150 gigabytes. So some of you who maybe do a lot of video could be up around there, but it's a large file, and hence that's why there are all these miners sucking up a lot of energy in areas where the energy is inexpensive. All right. Next thing. So, as you can imagine with Bitcoin, all this cryptology, governance, etc., has a lot of overhead associated with it. So we have, if I point to the area that has Bitcoin to it, there you go. That is public and permission, meaning public meaning that anybody can read it, and permissionless meanings everybody can have write access, meaning that they can do a transaction, and they can also be part of the governance. They do the mining and and be part of the governance that determines what the correct blockchain is. That has a lot of overhead. So Bitcoin right now has about 2 to 5 transactions a second globally. People a lot smarter than me have done some analysis, and depending on the person, they say its capacity is 7 to 10 transactions a second. In industrial blockchain, if you look at a full production supply chain, and this could be from fresh vegetables to the retail store, Walmart supply chain, for example, that when it's in full production, now it isn't quite there yet, but when it's in full production, that could need as much as 5,000 transactions per second. So obviously, the 10 transaction per second limit of Bitcoin for that kind of blockchain is not going to cut it. So the 36 consortiums that I looked at, they all use a private version and a permissions version. So what that means is you have to be either invited or you need to be applied to be part of the consortium. You are assumed to be trusted when you're accepted. You'll be closely monitored. If you do bad things, you'll be kicked out. And quite frankly, if you're not a part of the supply chain, that is going to be a serious hit on your viability of stay in business once the supply chain is in production on blockchain. So you're not going to want to be dishonest in any way, shape, or form. And tests have been done to say that in the case of the private and permission blockchain, they changed the configuration of blockchain to allow for higher speed. And they can get up to, tests have shown 10,000 transactions per second. So that is definitely viable for the higher scalability needed with a supply chain. Okay. Now I'll bridge over to the pilot programs that we've examined. The next slide is going to be somewhat of a summary. I'm definitely not going to go through all 36. I don't have time for that. And if I tried to, you'd probably get up and leave after a few of them. But I will show one for each one of the major benefits. So consortiums are pretty easy to get information about because they're out recruiting members. Nearly all the consortiums right now are in the proof of concept stage. There are a couple that are clearly crossed the chasm, and I have slides on them. I'll talk about them a little bit. So what I tried to do for each consortium is pull out the major reason people should join that consortium. What is the primary benefit? So the automated document sharing, that's the international trade example. So that's the business automation to get rid of email, fax, surface mail, couriers and stuff like that, to make that trade much more smoother, higher quality, et cetera. The next one, most common, is around recalls. That's in the food supply chain. I have an example of that. But the basic idea is instead of doing, when you find that something's bad in your supply chain, instead of doing a broad recall that costs tens of millions of dollars, because you know precisely where the bad source is, you can isolate that and do a less expensive recall. And the reverse logistics is allowing, this is happening in the drug supply chain, allowing retailers and the distributors to return drugs back to the manufacturer. And they may think, well, that can't be very big, but globally it turns out to be somewhere in the order of $50 billion worth of drugs won't get thrown away, they'll get reused. Non-trivial. What trust selling is all about is, because I know the source of the materials, I'm willing to pay more for it. So trust selling is a way for suppliers, miners is a key example, to get higher value, higher revenue, and higher margin for the products they sell. And then protecting IP is the next one. So because blockchain has two aspects to it. One aspect is around a database that everybody can read and share information. Another aspect of it is the multiple layers of cryptology. In this case of the IP protection, they focus on the multiple layers of cryptology and use that to protect their IP when they share it with customers, for example. And then operational data, that's where actually information from the control system is being shared so that the frenemies as a group can have higher operating performance. So this is now talking about the first one. The major consortium, this one is definitely crossing the chasm, is around international trade. You'll see here that, if I can make this work. Yeah. So this is across both Europe and the US. In terms of the participants, 5 of the 6 largest carriers, they carry, not saying 60% of the ocean-going freight is on blockchain, but people who manage 60% of the freight are part of this consortium and plan to transition to blockchain, right? 94 organizations involved, so you can see where this has definitely obtained critical mass, and as it grows the proportion of its business that's on blockchain, it'll obviously cross the chasm. The next one is the food supply chain. And I like to talk about this because it directly relates to everybody in this room because we all eat food. In the case of, let's talk about just for a moment about food contamination, like salmonella. It's a bacteria. So you cook your food, it kills the salmonella. It used to be all chicken. Now probably the majority or a good portion of chicken is contaminated with salmonella, but you cook the chicken and as a result you don't get sick. But fresh vegetables, lettuce, you don't cook that stuff. You eat it in a salad or whatever, and if that gets contaminated, you're going to get sick. Now, we have electronic health records. The FDA has access to that. So in 2019, there was a case where there was just 100 people got sick. 70 went to a doctor's office. 30 went to a hospital. Nobody died, thank God. Those 100 incidences were over a population that exceeded 100 million people. So it was literally 1 out of a million got sick. The FDA was able to identify the issue and drive a recall. Now, that's going to make you feel good because you know your food supply chain is a lot safer than perhaps you thought it was. But if you're in the food distribution business, that's going to scare the daylights out of you. Because the probability of a recall occurring that costs tens of millions of dollars went way up. Now, in the case of Walmart, what they did before blockchain is, it was an experiment, hands-on type of experiment. Some guy walked in a warehouse, he pointed to a case of mangoes and said, let's make believe we're having a recall, and these are bad mangoes, where did they come from? Well, using manual systems, it took Walmart nearly 7 days to find out where those mangoes came from. Obviously, that's too long and would have driven a broad recall in the tens of millions of dollars. They implemented blockchain. They went back, a different case of mangoes, obviously. Where did it come from? 2.2 seconds. Obviously now they have the information needed to reduce the size of that recall to the real source of the problem. A recall on average costs $10 million. For a big place like Walmart, it easily exceeds this. So this is a non-trivial cost, and with the analytics that's now available to the FDA, it's going to happen more and more. Ethical sourcing. Cobalt is used in electric motors for electric vehicles. There are a couple, Ford and Volvo, who really don't want to have cobalt in their car that was mined using slave labor or child labor. So there is a country, which I wish I could remember off the top of my head, that has supported the use of application of blockchain in their mines, in the mines in that country. And they can prove that the cobalt that they are supplying was ethically sourced, not using slave labor or child labor. And as a result, Ford and Volvo is willing to pay more for it. And as a result, that country gets not only more revenue, but also more profitability for the miners. And that country is actually using it as a core competitive advantage against other countries in the area that can't prove that it was ethically sourced cobalt. All right. So Volvo is, you see the last line there, went into pilot, but Volvo in this case is in production with it. Now I know that there are people in the room that either bought diamonds or received diamonds, so I thought I'd throw this one up because you all can relate to it. Nowadays, synthetic diamonds are so well produced, nobody can tell the difference between the synthetic diamond and a diamond that was mined naturally. So what the major miners of diamonds have done is they've started using blockchain to prove that it was sourced naturally, and there is a identification from mine to ring for that, so that they can, at the retail store, prove to the buyer that it is in fact a naturally mined diamond. That was announced in 2018, but I have a big anniversary coming up. My wife told me that she wants a big diamond, so not too distant future, I'm going to experience this personally. This one is the IP protection one. So there's a engineering firm in Singapore. Is that right? Yeah, Singapore. They developed a part that's used in airplanes. There was an airplane in Los Angeles that the part had failed in. The plane couldn't fly. That's obviously a problem because the part was out of stock locally. What they did is they shipped the 3D file, printed it locally in Los Angeles area, put it on the plane, and the plane could fly. They used blockchain to protect that IP so that the company in Singapore could be appropriately remunerated for its IP. Whoop. Did I hit the wrong one? Yeah, I did. Okay.
So they can use the plan for the printing and no one else can?
That's correct. So the question was, they used the plans for the printing and nobody else could use it. Well, that isn't exactly right. If anybody else used it, the firm in Singapore would know it. And they would know who used it because the 3D printer was identified and they could resolve that issue. All right. This one is the sharing of operational data. In Europe, there are a lot of distributed power generation, a lot of it being green, windmills and solar farms. So, right from the control system, they're making transactions into the blockchain so everybody knows how much power is being put in. Now, there is no storage in the grid, so if on a sunny day everybody started to dump a lot of power into the grid, there would be a problem, the grid would fail. So by sharing operational data, everybody scales back and they do that equitably, and as a result, the grid is sustainable, doesn't get overloaded, and continues to run. So by sharing data from the control systems, they can maintain and sustain a grid. All right. And I'll just say, all these examples essentially are, with one exception around the IP, is business process automation around frenemies. Next, I'll turn it over to the next set of speakers. Mohammed was not able to present. Verizon pulled him because the management decided that the blockchain application was part of Verizon's core competitive advantage, and they just did not want that exposed. So the Verizon example got yanked. So Joel and Emily will talk. I've asked Emily to talk a little bit more, stretch around the lessons learned. She's agreed to do that. And Shri manages a practice for blockchain, and I've asked him to talk about a few of the application examples that he has for blockchain, and he's agreed to do that. And one of them is about chocolate, making chocolate bars. So, heads up, that's going to be an interesting one. So I'll turn it over to Joel and Emily, and then when they're done, Shri will come up to the podium.